Hey guys, welcome back to Code Cream. Today we're going to be going over LeetCode problem number 15, Three Sum. This problem asks, given an integer array nums, return all the triplets, nums I, nums j, nums k, such that I does not equal j, I does not equal k, and j does not equal k, and nums at I plus nums at j plus nums at k equals 0. Notice that the solution must not contain duplicate triplets. So we can see what this question is asking based on the first example. We're given this input array, nums equals -1, 0, 1, 2, -1, -4, and we're given this output array of two triplets. The first triplet is -1, -1, and 2. The sum of these numbers is 0. The second triplet is -1, 0, 1, and the sum of these numbers is also 0. And so that's going to be the goal of this question, is to find all the possible triplets of a given array that add up to 0. The second example, there's only one possible triplet and it also does not sum up to 0. And the third example, there's only one possible triplet and it does sum up to 0, so our output is this array of this triplet 0, 0, 0. Now let's go over the algorithm, and I encourage you to stick with us through the example if the algorithm seems a little bit vague at first. It will become a lot more clear once we go through the walkthrough example later. We start by sorting the input array in ascending order. Then we iterate through the array with index I from 0 to length -1. We skip duplicates for I and values greater than 0. For each I, we use two pointers. Left equals I plus 1 and right equals array length -1 to start. Then, while the left pointer points to a number less than the right pointer, we calculate the sum, nums at I plus nums at the left pointer plus nums at the right pointer. If the sum is less than 0, we want to increment the left pointer because we want the sum to be bigger next time and our array is sorted. So if we increment the left pointer, there will be a greater number in the triplet next iteration of the while loop. If the sum is greater than 0, we want to decrement the right pointer because we want the sum to be smaller in the next iteration of the while loop. If the sum equals 0, then we've found a result, so we add the triplet nums at I, nums left, nums right to the result, and we move both pointers and skip duplicates. Finally, we return the list of unique triplets. Now let's walk through an example step by step. Let's walk through a step-by-step example of solving the three-sum problem using the array -1, 0, 1, 2, -1, -4. We start by sorting the array -4, -1, -1, 0, 1, 2. Then we iterate through the array. We start with I equals 0, which points to the number -4. Our left pointer is 1 because it's I plus 1 to start with, and our right pointer is 5, the length of the array -1. Our first sum is -4, -1, and 2 equals -3. This is too small, so we move our left pointer. Our next sum is -4, -1 again, and plus 2 gives us -3 again. This is because -1 is a duplicate number in our sorted array. This is still too small, so we move the left pointer again. Our next sum is -4, 0, 2 equals -2. This is too small, so we move the left pointer. Our next sum is -4, 1, and 2 equals -1. We're still too small, so we move the left pointer. The left pointer is no longer less than the right pointer, and we end the iteration. Then we iterate again with I equals 1. It points to -1. Our left pointer is 2 for I plus 2, and our right pointer is 5 for the length of the array -1. Our first sum is -1 plus -1 plus 2. This equals 0. We found a triplet, so we add that triplet to our output, and we move both pointers. We skip duplicates for the left pointer. Our next sum is -1, 0, 1, which gives us 0 again. We found a triplet again. We move both pointers. The left pointer is no longer less than the right pointer, so we end the iteration. Next, I equals 2. This points to -1 because there's a -1 again. We skip duplicates, so we skip this iteration. Next, I equals 3. It points to 0. The left pointer is I plus 1, so it's 4, and the right pointer is 5 for the length of the array minus 1. Our first sum is 0 plus 1 plus 2. This equals 3. It's too large. And then we decrement the right pointer. Our left pointer is no longer less than our right pointer, so we end the iteration. We skip 4 and 5 because the values at those indexes are greater than 0. Because the value that I points with is going to be the smallest element of the triplet, if it's greater than 0, we know the sum is going to be greater than 0 and we won't find a result, so we can skip those values. Finally, we return the two triplets we found, -1, -1, 2, -1, 0, 1. The complexity analysis for this problem is as follows. The time complexity is O of n squared because we have nested loops. The space complexity is O of n or constant depending on the sorting algorithm you use. Now let's jump into the code. We start by sorting our array, then we initialize our result to be an empty array. Then we say for I, A, and enumerate nums. What an enumerate does, it's just a Python way of giving you the index and the element at that index all in one go. So the I is the index, the A is the element at that index. For I, A, and enumerate nums, if A is greater than 0, we break because again, we know that if A is greater than 0, our sum is always going to be greater than 0 because A is the smallest element of a triplet. So we know that it's not going to give us an accurate result. If I is greater than 0 and A equals nums at I minus 1, continue because we want to skip duplicates. Then we initialize our left pointer to be I plus 1. We initialize our right pointer to be the length of nums minus 1. Then we say, left is less than right. We calculate our sum, nums at left, nums at right, A. If the sum is less than 0, then we increment our left pointer. If the sum is greater than 0, we decrement our right pointer. If the sum equals 0, then we append that result. We increment the left pointer, we decrement the left pointer, and we skip duplicates using this while the left is less than right and nums at L equals nums at L minus 1. We increment the left pointer, that's skipping the left duplicates. And finally, we return our result.